Hi everyone, this is Brian from Kaizen Academy, and today we've got another question for you all. So this question here was requested by Natalie. It's a 2-unit motion question. So it's a bit tricky in terms of the wording of how we do things, but let's get into it and see how we go. So a particle is projected vertically upwards from a point 2 meters above horizontal ground. The displacement at time t is given by x equals 24.5 t minus 4.9 t squared. So quickly, let's draw what this question is asking for. So we've got a particle, it's projected upwards, but the particle starts 2 meters above the ground. 2 meters, this distance here. And displacement is given by x equals 24.5 t minus 4.9 t squared. So one thing unconventional about this question actually is that when you sub in t equals 0, time equals 0, the initial displacement here is actually equal to result in x equals 0. So what this really represents, this equation here, is our displacement from this 2 meter point above the ground. So let's keep that in mind when we do all the questions. Let's start. So find the velocity of the particle. So to find velocity of a particle, we have a displacement time function, which differentiate this function with respect to t, and we'll get our velocity function. So let's do that. Cool, so that's our velocity function. Nice and easy, just differentiate this with respect to t, and we've got that. Next part, find when the particle comes to rest. So what does it mean when it says when the particle comes to rest? This means when the velocity becomes 0, so when it stops moving, right? And we have a velocity function right here, so let's find out when this particle stops moving and comes to rest. So we let v equals 0, and we're trying to find our t. And we have this equation here, so let's do it. Cool, so we see here that the particle comes to rest when the time is 2.5 seconds after being projected. Cool. So next part, find the greatest height of the particle above the ground. So let's try to understand this conceptually first. So when this particle is projected from its initial point, eventually it's going to reach somewhere up here, and eventually it's going to run out of steam, and it's going to eventually fall back down. But at that point where it runs out of speed and comes back down, the velocity will be 0, right? When you throw a ball upwards, eventually it's going to have to slow down, stop, and then come back down, right? Due to gravity. So before it comes back down, however, it stops before it comes back down. So we know that it stops at 2.5 seconds. If we put this 2.5 seconds into our displacement function, we will know at what point it stopped, what height it stopped at. So let's do that. But we're not finished at this point yet, because this gives us the displacement from our 2 meter point. If we want to find the actual greatest height, we've got to add another 2 meters onto this, because we started 2 meters above the ground. So last part of the question. Find the length of time for which the particle is at least 21.6 meters above the ground. Okay, when the particle is 21.6 meters above the ground, what that really means is when x equals 19.6 meters. So why is that the case? Because we started with our particle 2 meters above the ground in the first place. In order to get the particle at 21.6 meters, all we've got to do is actually get a displacement of 19.6, right? Because with the 2 added on, that will be our height that we asked for, 21.6. So now I've got to know how long is the particle 19.6 meters above its initial position. So how do we do that? Well, first of all, we've got to understand at what time period first our particle is 19.6 meters above its starting point. So let's write our equation to get that, and then let's try solve that equation there. So when is 24 our displacement function here? When is this above 19.6? So when we solve this, we can know at what time period our particle is above our 19.6 meters mark, and then we can find the time, the length of time the particle is above. So let's solve this. Cool. So at this point here, what do? Right, we've got to know when is t less than 0. So we know that this is because of this is a parabola. When is this parabola less than 0, also known as negative? So let's draw this out. So we know the roots here is 1 and 4. So 1 and 4. And it's positive above here and positive here, but between 1 and 4, it is negative. So that's when we know it's negative. So t is between 1 and 4. It's negative. So what does this really mean? What this really means is that we know between 1 second and the 4 second mark, we are above our 19.6 meters, right? Therefore, if it's between 1 second and 4 seconds, we know in total we've spent 3 seconds actually above 19.6 meters. 19.6 meters here actually means 21.6 in reality, because 19.6 meters is just displacement from the original position. So let's conclude this. Therefore, total time spent above 21.6 meters is 3 seconds, right? Because between 1 and 4 seconds, that's when our particle was above at the 21.6 meter mark. Okay, cool. So what was tricky about this question? I think the tricky part here is knowing that despite our displacement function not starting actually at 2, we know that despite this equation here, what it actually means is our displacement from our initial position, and our initial position is 2 meters above the ground. So once we get our headers around that, this is just the ordinary applying the basic formulas of our motion questions. So this one here, this one here, this one here, this one here, we've got to take in mind, part 3, we've got to take in mind, keep in mind that the particle did start 2 meters above the ground, so the actual height that we're actually having has to be added. Add 2 onto this, and the length of time spent above the 21.6 meter mark. We've got to understand that what this really means in terms of x, our displacement, is 19.6 meters. And if we can find the time periods for which our particle is above 19.6, which is between 1 and 4, we can find the total time spent above that 21.6 meter height. Cool. So great question, Natalie. So good one setting it in, because it is quite confusing, definitely not straightforward at all compared to your usual motion 2-unit questions. But cool. If anyone else got any questions, 2-unit, 3-unit, feel free to send them in. But otherwise, make sure you like the Facebook page and stay updated with any other questions that eventually come out. Thank you.